everyone, and welcome to this Tinkershop tutorial. My name is Martin from the Innisfil Idealab and Library, and today I'm going to be walking you through building a simple circuit controlled by the microbit to detect the level of moisture in a container of soil. So, one of the hardest parts sometimes about growing plants indoors is knowing how much or how often to water them. And if we get it wrong, it makes for unhappy plants. So hopefully using this microbit soil moisture meter, we can get it right every time and grow happier and healthier plants indoors. So if that sounds interesting to you, then let's get started. The materials we'll need are 1 cup of soil, 1 microbit controller, 1 micro USB cable, 1 battery pack, which is optional, 2 nails, and 2 alligator clips. To build our circuit, we're going to need our microbit, we're going to need our 2 alligator clips, and the 2 nails, as well as your cup of soil. So start by attaching one end of an alligator clip to pin 0 on the microbit and the other alligator clip to pin 1 on the microbit. Then you're going to attach the other end of each alligator clip to the top of each nail. And then once you've done that, just insert each nail into your cup of soil, like so. And there we have it, your circuit is complete. Okay, so we're ready to write the code that's going to control our circuit. So you're going to go to makecode.com and then click on microbit, and then click on new project, and give your project a name, something like soil moisture meter, and click create. And so before we write code, let's just think about the circuit that we created and how we can use that to measure the level of moisture in our soil. So if we look at our circuit, again we have a crocodile clip going from pin 0 to a nail in our soil, and then we have another nail on the other side of our cup of soil connected to an alligator clip that loops back to pin 1. And so the idea here is we will send an electrical current from pin 0 to the nail in the soil, and pin 1 connected to the other nail in the soil will try to get a reading of the electrical current between the two. Now it just so happens that the more moisture in the soil, the more conductivity the soil has because of the mineral content in the water and the nutrients in the soil. So when our soil is dry, we'll get a very weak signal. The signal will weaken between pin 0 and pin 1. When we add more water, it'll add more electric conductivity, and it'll be able to pass the signal between the 2 nails a lot better, so we'll get a stronger signal. So we can measure that signal and then find a way to display that on our microbit so we can get a good reading. So let's jump back into our code and make our code that can send and receive these signals and display them on our microbit. Okay, so the code for this is pretty simple. We're actually going to get rid of this on start block, and all of our code is just going to be placed in this forever loop. So using the forever loop, it's just going to constantly run our code over and over, looping through it. And this way we'll be able to get a continuous reading of our soil moisture level. So to start, we're going to want to send that electrical signal from pin 0. So you're going to go into advanced and then into the pins drawer and grab this analog write pin 0 to 1023 block. So this will write or send an analog signal from pin 0, and basically you can set it either low or high. We want to set it high. And this 1023 will know when we read the signal, its highest value will be 1023. So the next thing we'll want to do is get a reading. So pin 1, remember, it'll read this signal after it's been passed through our soil. So we'll start by creating a variable. So click on the variables drawer and then make a variable, and we'll just call this variable reading. And then once you've done that, grab this set reading to 0 block and drag it under the last block. And we're going to want to set this reading to whatever value we can read from pin 1. So go into pins and then grab analog pin 0 here, snap that in to there, and make sure you set that to pin 1. So we're getting a reading which is set to our pin 1. So it's going to read whatever it's receiving. So remember, we're sending the signal from pin 0. It's getting passed through the soil, and then pin 1 is reading that signal. And remember, the more moisture, the stronger that signal will be. The drier the soil gets, it'll weaken that signal through the soil. So, I mean, now we're sending the signal and we're getting the reading. That's kind of most of what we have to do. Now we really just have to display the reading on our microbit. But what I actually want to do, just to save a little bit of power, is right after we've set our reading, we'll go ahead and turn our analog write pin back down to 0, so it's no longer using electricity to send a signal. We've already got our reading, so we no longer need to be wasting electricity. So this will save you a bit of battery power. So go back into the pins drawer and grab the analog write pin block again, drag that underneath here, and now we'll just set this to 0. So we'll just shut that signal off. Again, we've already got our reading. Okay, and so now that we have our reading, we can find a way to display it on our microbit so that we can read it. So to display our reading variable on our microbit, we could do something really basic like just show number and the reading, but to make it look more like a meter, we can use under the LED drawer, grab this plot bar graph block, drag that into our code, and so basically what this does is it'll take a value, so we can give it our reading value, and it will use that to plot a bar graph up to a maximum value that we can specify. So we're going to plot a bar graph of our reading variable. So go into variables, grab the reading variable and drag that into that first slot. And then we have to set the maximum value. Well, the maximum value is going to be 1023 because that's the full signal that we're sending from pin 0. So that's the maximum that our reading can be. So we'll graph this up to 1023. Great, and so we could probably stop here. That's basically going to do what we want. But let's say if we want to actually also get the exact number of the reading, we can do that by detecting a button press. And then so if, say, button A is pressed, we'll show the actual number. So the bar graph will be a good quick visual indicator, but if we want the exact number, be a bit more scientific, we have the option to show the actual number of the reading. So to do this, we'll go into logic and grab the if statement under conditionals. Now, if you watched our other videos, you should be familiar with the if statement. Basically, if a condition is met, it'll run the code inside it. So what we're going to do is say if button A is pressed, then we'll show the number of our reading. So go into input and then grab this button A is pressed block and drag that into our condition of our if statement. And then, so if button A is pressed, we'll show the number of our reading. So we'll go into basic, show number, drag that into our if statement, and then go into variables and drag reading into the show number block. Okay, so now we'll be able to see a visual representation with a bar graph of our reading. But if we want to see the exact number, we'll press the A button and it'll show us the number for our reading. And you can't see it on the simulator because it's not hooked up to our circuit. So it's not going to show anything. It's just showing this one dot because it's basically not getting any reading. So you'll see it in action when we actually hook our microbit up to the circuit. The last thing I want to do though is add in a little bit of a pause here, because this forever loop is going to go really fast, and when you think of the moisture in your soil, it doesn't really change all that fast. So by adding in maybe like a 5-second pause here at the end, we'll save ourselves from sending this signal so rapidly, and it'll give our battery a bit of a break. So let's just go into basic and then down to pause, and we'll add in a 5-second pause. Now, if you really wanted to save battery, you could add in a greater pause than 5 seconds. But the problem is with the button press, if we're pressing our button and let's say we have this pause for a minute, it's not going to get that button press for like 5 minutes. So 5 seconds means if we're pressing the A button to get our reading, at most we'll have to hold it down for 5 seconds. So it's kind of the best of both worlds. So that is it for our code. Go ahead and save it to your computer and upload it to your microbit, and then we'll test this out when it's our microbit is all connected to our circuit running this code. Okay, so the first thing you're going to need to do is connect your power source to your microbit. So either a battery pack or a micro USB cable connected to a computer. And so the microbit powers on, and after 5 seconds we get our initial reading, which is quite low. If I press and hold the button for about 5 seconds, it displays the number, so 327. That's a pretty low reading. So next we'll give it some water and see what happens. Okay, so we'll start by just adding a little bit of water to our container. Whoa, and there we can see our bar graph goes right to the max. We'll add a little bit more. And then we can press the A button for about 5 seconds to get our exact reading. So we get 928. So that's close to our maximum value, but we can probably add a little bit more. There we go. And we'll press the A button again. And it should have gone up a little bit. So we get 10, 19. So yeah, it's going up, but we could add a little bit more. Hoping for close to 1023, which is our max reading. So let's try it after one more watering. $10.20. So that's close enough. There you go. Our working soil moisture meter and perfectly watered soil. So I think this is a fun little project and a great way to get into building some physical components and circuits that interact with your microbit. If you enjoyed this video and you want to do some more projects like this, the makecode.com website is full of great microbit projects. I actually pulled this project from here. You can see the soil moisture tutorial. And if you like this, there's a plant watering project that builds onto this, where it not only detects the moisture of the soil, but based on the reading, it will automatically water your plant. So a little bit more complex, but could be a lot of fun. But anyways, guys, I hope you enjoyed watching this video. I hope that you learned something, and most importantly, I hope you have a great day. Thanks.